So, hello everyone. This is Stephen Downs calling in from the beautiful little town of Grasshopper. We've got this little town of Grasshopper, the beautiful little town of Castleman, Ontario. We have another e-learning activity happening for you. I've got with me Tony Hirst from the Open University
Hello.
of Great Britain. Or of the UK, I should say, shouldn't I? It's the Open University of the UK. And we're going to talk about the cloud. And we're already up to one viewer. Hello, viewer. I hope it's not me. So, Tony, welcome to eLearning 3.0 and welcome to week 2 and the session on the cloud and all that.
Thanks for the invitation.
How are things in the UK?
They're good. Yeah, just coming up to sun will just start to set any time. We've just changed our clock, so I'm getting used to the, losing the hour. Yeah, in work in Milton Keynes, so home of the Open University. Where, although we're a distance learning organisation, we do have a home campus. Although there are never any students on it, apart from research. So, yeah.
So, what do you do for them at the OU?
I'm an academic, so my title is Senior Lecturer in Telematics. I originally joined what was a telematics department. It came out of an electronics department, and it was looking at communications and I guess the web was just emerging when I joined. So it was looking at the sort of communications, social communications, and the department has transformed over the years. I'm now in a computing department, and I work primarily on a course looking at databases, data management, and data analysis. But I spend a lot of time playing with emerging technologies that are still emerging, as well as open data sets. So I got looking for tools to lower barriers to entry to using open data, and then seeing what we can do with it.
Yeah, I was going to ask about that because, of course, that's pretty much the topic of today. But you've been looking at things like, well, cloud and data and all of that. So the first question is why? Why that?
Right. Well, as I mentioned, we work for the Open University, which is a distance learning organisation, and we have. When we delivering courses with computing needs, our students are essentially bring your own device students. So we have no control over the software platforms or the computing environments that they work with. We set a minimum specification when we run courses on the sorts of computers that people can use. And it's quite a low specification. It might be a 5, 6, 7 or 8-year-old machine. So something running Windows 7 with a small amount of memory. We're supposed to be able to support students working irrespective of platform, so Windows, Linux, Mac, and we've also faced, I'm not sure we're seeing much signs of it yet, but there's the potential of students whose main computer will be a tablet or whose main computer will be something like a Chromebook onto which they can't install software, or maybe even a phone. So one of the issues that we face, particularly in computing, where on the databases course, we have quite a complicated software environment we want students to run. We've got the teaching environment. We've run several database servers. We need to find ways of delivering software to students that we can manage and we know will run. And so one of the things that I've been looking at is using virtual machines to deliver software environments. These virtual machines, the one we deliver for the database course I work on, that is actually quite a large physical virtual machine that students can download and run on their computer, whatever computer it is, using an application called VirtualBox. And we give them a virtual machine, which is essentially a box that contains its own operating systems and applications that we've installed onto that lets the students run this environment on their machine. Potentially, we could also run those environments on our own servers. So the idea that I'm working towards is finding ways of packaging software up so that we can give it to students to run on their own computers if they can. If not, we should be able to host those self-same environments and allow students to access them. And the software applications that I'm particularly interested in are ones that expose interfaces through a web browser, so an HTML interface over HTTP, so you can just log in on a local network or over the internet. So for me, it's a way of providing software to students. It's in the data world. It's also useful in research. If people working in a research environment have got a complicated scientific software stack that they're working with, they may well be able to write pieces of code that they could share with other people, but other people can't necessarily run that code because the environment isn't set up. You can't just install, you've got to install lots of other bits of software. So virtual machines and running things in the cloud allows us to build pre-built environments within which code can run, and we know it will run. It doesn't require an individual to set up an installation or configure software themselves.
So what kind of setup would they need to run one of these things on their own computer? They're not going to do it on a Chromebook, obviously.
Well, no, but emerging Chromebooks you can, I think, start to. So there's two things we use. One is an application called VirtualBox, which is a piece of free software. You can download it, run it on most platforms, originally published by Oracle. And so that allows you to install like a big virtual machine. So this is something that runs a complete operating system, and then you can install software on that, or we provide virtual machines that contain the operating system and the software repackaged. There's also a lighter sort of way of packaging up applications, which is using something called containers, Linux containers. And the most popular environment for that at the moment is something called Docker. And what Docker containers let you do is it's essentially a more lightweight way of creating and launching a virtual machine. So you can run VirtualBox on your own computer, or you can download and install this application called Docker, and then Docker allows you to run applications within this Docker virtual environment. There is an issue with Docker on Windows computers, that Windows has got its own virtualization system called Hyper-V, which allows you to run virtual machines, and that has to be disabled when you're working with, maybe not with Docker. You definitely have to disable that when working with the VirtualBox virtual machine. And you mentioned the Chromebooks. So I think one of the things the new Chromebooks will support is the ability to launch Docker containers. I haven't had a chance to play with that yet. I don't have a Chromebook that's powerful enough to explore that, or new enough.
That would be pretty nice. My experience with Hyper-V is that it's the opposite for Docker and VirtualBox, which of course figures, right? Because it means you're either running Docker or you're running VirtualBox. But if you're running both of them, you're always switching it on and off in between. Yeah. Very annoying. So it'd be interesting to see loading Docker.
I mean, I could show you. There's an application you can use to run Docker from a visual environment, but most of the time you run it from the command line. What I'll do is, if I just find Docker Hub, there's a site called Docker Hub, which I will just load that up and then share the screen.
I'm looking for it myself.
Yeah.
Dockerhub.com. Oh.
It's there we go. We should be up now. So hub.docker.com. So I'm actually logged in, so it's showing me the containers that I've uploaded. So this is a place where you can build these little containers, pre-packaged tools, and upload them to Docker Hub. And then once they're published there, other people can download and install these applications on their own computer. So I can just show you one way I can do that.
Yeah, why don't we do that?
So if I just get a terminal up, should have my terminal.
Yep.
So, sorry, I should have cleared the things. So here I've got a command which is used to launch a Docker container. The Docker is the name main application, then I'm going to say run. I want to run something. There's a couple of flags in there. -D is just is detached. It tidies up after itself. -P, which is for mapping ports. So I'm going to run this particular container runs an application called OpenRefine, which you can use for tidying data sets. It's a Java application, so if you wanted to run it on your own computer, you'd have to download and install the right version of Java, and then you'd have to download and install OpenRefine, and then you'd have to start it up and make sure it works. But what I've built a container that pre-packages Java, it pre-packages OpenRefine, and we should be able to run it. The -P thing in there, that's to map the ports. When this application runs inside the container, it runs on a particular port, number 3333, and I'm just showing how I can map it to another port, which we'll be able to see when I actually log into it through my browser. So if I run that, it says it can't find the copy locally.
Right, of course, yes.
And and of course I've got something else running.
Yeah, because there's always something.
I demoed this morning, and this is why I've still got things lying around, I think.
Yeah.
Right.
So that looks good.
Yes. So what it done, if I'd cleared it away, I thought I had cleared it away. It would have downloaded all the elements that I need for this container. This should be running now on port 3334. So if I go into my browser,
so we're not seeing your browser because you're sharing the window, I think.
Share that up.
Yeah.
There we go. So now I've got localhost, which is a local network running on my computer. On 3334, I've got this application running. I should have shown you that not running a moment ago.
Yeah. Oh, well. And you don't have to do anything special to have localhost. The Docker does that all for you. The container.
It does, yes. It runs it on the local network. So what this means is that I can just launch these applications from the command line or from an application called Kitematic, and it should ideally just run. It might download and install the various bits in the Docker container, but then it provides you with a way of accessing this. It also means that I'm not actually installing OpenRefine or Java on my computer, so I'm not contaminating my environment. I can just destroy this application when I've finished with it. I can also share files, so I've set this up so that I can, when I save files, it will actually save it to my desktop. So I can share a file from my desktop into the computer, into the container, work within the container, save files, and they will then appear back onto my desktop. So the application itself will run without me having to install software that might upset the rest of my setup. But I can save and open files that do exist on the desktop.
And being able to save locally is important because everything that's in the Docker container is going to disappear when you stop the Docker container, right?
Yes. And another thing I can do is I can run this same container somewhere else. So if I go to, I use an online host. If you want a quick demo of this.
DigitalOcean, flavor of the day.
Yes, DigitalOcean is an online host. You can get free credit to try things out on this. I can launch a server on this machine. So I can create a server. There's in the tabs. There's an image there called one-click apps. Have you got that? See that? Okay.
I'm seeing create droplets. Yep. Yeah.
And so there's a virtual machine there that's pre-built with Docker installed. So I can select that. I can choose the size of server that I want to launch, so I can choose any size I want, and I'm rented. I pay rental by the hour, so if I start and stop machines, it doesn't necessarily cost me very much. I'm going to run a 4 GB machine here with 2 CPUs and 4 terabytes of storage that I can get for 3 cents an hour, so it's not too expensive. I can choose where I want to run this server, so I'm not far from London, so I'll launch one that's quite close to me. And there's some setting here about SSH keys. So I've loaded some credentials into my account on DigitalOcean, and that's just going to allow me to Shouldn't share that really, should I?
Oh, yeah.
Never mind.
I think you'll be all right.
Yeah, I'll change those keys maybe.
Yeah, maybe.
Oops. So what I can do, I can just create that machine.
It's not your fault. They shouldn't be popping it up on the screen because, you know, that's analog. I mean, you know.
I hadn't realized it previewed it until just this minute. So there we go. So what it's doing, it's launching a server now, which take a few seconds. And then when it's got a server, it'll give me a URL, a web address that I can actually look at that. So should come up any second.
So basically what it's done here is that it's taken the Docker container, put the Docker container on a Linux server somewhere out there, and it's firing it up, right? What
this one's actually doing, it's launching a complete virtual machine on the server. The server it's got Docker installed, and then I'll be able to log into that. It's taking a bit longer than it does normally. Maybe it's a busy time of the afternoon, or maybe it's a slow time of the afternoon. They've not got lots of machines up and running.
I don't know. Maybe you should check your credentials again and make sure they were right.
Yeah. I don't think I've used all my credit. Shouldn't have. Not at 3 cents an hour.
Yeah, no.
I've got at least $5 in there.
Yeah. DigitalOcean. Yeah, they tell you to put $5 in, and then you use that up, and then they keep sending you, oh no, you've run out. I forget exactly how the emails go, but like, whoops, you've run out of digital credit.
Yeah.
But I mean, it really is quite cheap, though. Think of
it. Yeah, you can run things for, I think, what did it say? $20 a month was the price on that machine.
Maybe you just started up too small a machine for your container.
No, I mean, as I say, I did a little demo this morning, and this is a similar configuration. It's just
being slow.
It's just being slow, yes.
Oh, is that you or it?
No, I was. Yeah. So it's running. Is there a thing there? Maybe something. So I've got a URL that we can see. If I just go to that, we shouldn't be able to see anything. So I've just taken the URL. If I can try to log into it.
We'll see what happens.
So I can try to log into that machine.
I can say from experience, normally it's like a lot faster. It's just sort of goes.
Yeah, I think it was maybe that just the display hadn't updated.
Yeah.
I don't know if that's interacting maybe with the screen share. It shouldn't, should it? But, I'm happy to be superstitious about how computers don't work.
Yeah.
Anyway, so I've logged into that machine.
All right.
And what I should be able to do is
now I'm still seeing your DigitalOcean screen here.
Okay, hang on a second.
Oh, so the new tab isn't showing. That's why. Don't know why.
I just need to get to this one. I'll share to my terminal. Hang on, here we go. I'll share to my terminal. Okay, what I did.
Okay. So you've SSH'd in, and it used the credentials that you gave it. You just have them as they're stored somewhere, or where are they?
They're stored on my machine, so the matching pair, so I can just log in without having to provide the password. And now, if I run a variant of this command that I ran last time. Now I haven't tested this, so we'll see if this works.
Let's see if this works.
I'll try it onto port 80, which is the normal HTTP port. So that's the same container that I ran last time. So there, it can't find the container locally.
Right.
It's downloading the container now.
And that looks good.
And if I go back to share the other screen.
So the tricky
works.
Oh, there we go.
Fingers crossed this works. Right, so there we are on that IP address. So if you go to that IP address, you should be able to see this application as well.
Well, let's test that. So what is it? 167.99.202.150. 167.99.202.150. And so I'll come over here and share my screen. And what do you know? There it is. Right. I don't know what it does.
Right. So OpenRefine is a tool for cleaning data sets.
Okay.
So it's like a spreadsheet interface-ish, and it allows you to essentially do similar sorts of things that you might do in a spreadsheet, to just tidy up columns and rows of data. I should have found a useful file to do that. Yeah. So it's basically a tool for data cleaning. That's probably a good basis for a separate conversation, that one.
I thought I was sharing it and I wasn't sharing it, but now I'm sharing it.
Right.
So this is pretty neat because, like, well, first of all, from beginning to end, that was all in real time, and that's how much time it took you to set up and run this application.
Absolutely.
And this is just this is a data cleaning thing, but you could use it to run advanced machine learning or graphing applications, etc.
Yes. If you go onto Docker Hub, am I still sharing? So stop sharing. That's what I need to do. We'll get lots of echoes. Yes, there's lots of pre-built applications in containers that you can run and launch that other people have built, or you can assemble your own computing environments, run your own applications, or if you're working with a research group or a team or a bunch of students, you can build your own containers that contain just the software they need, and then allow them to run those again with just a single line. You type Docker run the name of the container. If it hasn't got the copy locally, it will go off and find it. Yeah, so it's a useful way of providing runnable software. What it does require, of course, is that you need a server to run it on.
Yeah.
So there's I could show you maybe another application that I use quite a lot.
All right.
Which is something called Jupyter Notebooks, which is an environment. It's a read-write environment for writing literate narrative computing scripts, literate programs. And the notebook system I use is one called Jupyter Notebooks, but it's actually part of a wider ecosystem of tools and tooling. And if I go to let's think where I've got something. I've got a repository on GitHub. My username there is Psychomedia, and I've got a repository called Show and Tell, where I've got various builds for different sorts of machines. There's various branches in there, and what I'll do is I'll go to maybe the chemistry one. Oh, shall we go to the chemistry one? What subject do you fancy having a quick look at? Chemistry, electronics?
Well,
music?
I'd say philosophy, but maybe not.
I haven't got any philosophy at the moment.
Yeah, that's kind of what I thought. How about music? Yeah, let's do music.
Okay, I'm just fingers crossed that I've got something built. So on this repository, I've got a couple of files in there. I've got a requirements.txt file, which says that these are some packages, they're Python packages that I want installing into a container. There's just a list of package names. And there's an apt.txt file, which is where I've actually listed the names of some Linux packages that I want installed in the container.
No, we're not seeing your screen. We're seeing you right now.
Sorry.
Nope, no problem.
I tried that one. No.
I forget that too. There we go.
Are we there?
Yeah.
Okay.
Show and tell music.
So with some Python package names in.
Mm-hmm.
This is ones that I want the system to install for me. And I've got an apt.txt file where I've got some Linux packages that I want installing. And also on this repository, I've got this button here that says Launch Binder.
Yeah.
And what that does is that generates, that takes the copy of the address of this repository on GitHub, and it will run it in a site called mybinder.
Aha.
So here I've got
There it is.
mybinder.org, and then some bits in the path, and then Psychomedia Show and Tell, which is the name of the repository, and then Music, which was the name of the branch. And what it's done is I'd previously built the container. It can take quite a long time to build.
Mm-hmm.
It launches this thing called the Jupyter Notebook server, running this application called Jupyter Notebooks, which is a notebook interface that allows me to write documents, or write literate programs. So this is an actual notebook. Have you got that there?
Yeah, we can see that perfectly.
So the notebook harkens back to the early days of the original inspiration of the web. It provides you with a read-write environment.
Yeah.
So I've got something that looks like bits of HTML text here. If I double-click in there, then it changes. You know, the look changes, and this is actually an environment where I can type things. So I'm actually typing in a markup language called Markdown, so I can say hello world, and I might italicize the word world. And if I press the run button on the toolbar, it converts that Markdown, it interprets it as HTML and displays the text for me. So I can use this to write myself bits of text.
And I can save this, of course, obviously.
Yes, and I can save it. I'd save it into the container using the save button, which would actually be destroyed when I finish working on mybinder. Or I can go to the file menu and I can download the notebook. Its raw format is IPyNB, which is a JSON format. That's what I could save the file to my desktop if I wanted to keep a copy of this.
Right, and then you might upload it to GitHub or something like that.
Absolutely, yeah. BinderHub doesn't allow you to write back to GitHub; it just copies from it.
Oh, that's too bad.
So as well as the text cells, so I've got another cell here. The hash is a level of heading, so this is second level heading. I've got these grey cells, and these are where I can write program code. Now, by default, can't get that message to go away. It'll go away in a minute. By default, I write Python code in here, but you can attach different kernels on the back end that could interpret other programming languages. If I wanted to write R code, which is used for writing statistical programs, or Julia, another sort of data analysis language, I could write code for those languages and run them in these cells as well. I have to attach a different thing on the back. But I can run this code, and what this one's doing, this is loading various packages relating to music. At the top, I've got one here called Music21. And what I'm doing is, when I'm selecting a code cell, I'm pressing the run button, and it's taking a copy of the code that appears in the cell, sending it to this kernel on the back, which is running Python, executes the code, and then the result of executing the code, it passes the response back for display in the notebook.
So you're running live code right on your web page.
I should actually, if I clear all the cells, I'll clear all the cells, and we can start to run through these things. Oops. Start to run through these things.
Have to go
so when
from
there's
the
a little
beginning.
asterisk in the cell, it shows that it's doing some computing on the back. This Music21 package is a package for working with musical scores. So one of the things I can do here, there's a language within the Music21 package called timing notation, which allows you to write just simple notes. And I can then render those notes. Those notes are stored as a sort of a musical object, and I can then render those as a musical score. So these notebooks were originally defined for, in the code areas, you would originally have written like scripts to analyze data sets and produce charts and graphical outputs. But there's lots of other packages around that can integrate with notebooks to allow you to do other sorts of computing. So one of the things I'm quite interested in is environments that allow people to generate media assets, essentially, in a reproducible way. So here, if I want to change my musical score by adding some notes, I'm going to just type in the focus here. I'll type in a few more notes. They're meaningless to me. I'm not a musician. But I can read,
you've added them
and update the output. So this allows me to essentially, use text to write the definition of things that I can then render as objects. Another nice thing about Music 21 is that those same notes that I've put into this object, this S object, that I can render the picture of, I can also play as a MIDI file. Now, I don't know if you hear the audio, you probably don't.
Yeah, I hear it.
You do, right, okay, so...
Yeah, it was going really good, and then it sort of went off kilter the last few notes there.
So there, I've generated this object. I can view it visually as a score, or I can play the notes through a MIDI player. And that doesn't require me, needing to know any programming or anything. The Jupyter Notebook environment itself has got machinery for displaying images, for displaying videos, for embedding media players. And the packages, an increasing number of packages are being designed to output stuff in a way that's sort of sympathetic to the notebooks and hook into the various bits of notebook machinery that allows it to render these rich outputs.
So if we think about the advantage of this means that from this environment, you can change any aspect. It's not just changing the notes, but you can change any aspect of this program and then run it and see the result, or in this case, hear the result right away.
Absolutely, yes.
Of course, you can break the program too, but then you just reload the page.
Yeah, but another thing is that I could, if I download this file and pop it back into the repository, the next time I launch that repository from Binder, it will have this version of the file. Or if I want to share this notebook with you, I can share. So this is where the two parts of the jigsaw come together, really. One is I've got a file like this that has maybe got some words and some computer code in. But if I just gave you this notebook, even if you'd got your own Jupyter Notebook server to run, the code wouldn't necessarily execute, because all the packages that I'd installed to make it run, you wouldn't necessarily have on your machine. So I could give you the notebook and you could try to run it, but it might say, well, this package doesn't exist.
So what I'd really want is a container with all the packages already installed.
Yes. Yes. So one of the things that we could do from the show and tell, my sort of show and tell environment, if I go back to the one we were in music, weren't we? In the music one. So one of the things that I could do is that I could write another bit, a short Docker file that would pick up elements of this and use the requirements and the apt package to essentially build a container that I could publish somewhere. And then you could just download and run the container pre-built. Another thing about this repository is that it does specify the requirements of all the packages that you do need to know. So I could use this repository to build and publish my own container that then you could take off the shelf. And one of the ideas that I'm trying to work towards is this idea of digital application shelf. So you've got these things that are pre-built, pre-packaged with content that generate their own media assets, and they work without the user having to install any software at all.
That would be really nice. I'm looking forward to that day.
Yeah. We're slowly getting there. The jigsaw pieces are starting to fall together, I think.
And what's really interesting is that this is stuff now that will be available not just to corporations or service providers. It'll be available to average people, so that anybody with the inclination will be able to do this.
Absolutely, yes. Yeah, I mean, for me, computing's one of the things that makes computing difficult, or getting started, is it's just the practicality of getting started.
Yeah.
And one of the things that I like to think of this, if you think back to the early days of the web, which I'm guessing you can remember as well.
Yeah.
One of the reasons the web took off so very, very quickly was because of a magical thing in your browser called view source.
Yeah.
Which you can still get in a browser nowadays, but increasingly the source code is quite scary. But in the original days of the web, it was quite easy to view the source code of an HTML page, look at the finished rendered HTML page, and then just pattern match yourself. You know,
Yeah.
Well, this word is this bit in the view source file, and you could change those words or sentences in the view source file, and then republish the page, and your words would magically appear as the web page. It's not so easy to edit pages anymore, but we used to be able to do that with early HTML pages. And I think
how I learned, yeah.
A lot of them are at a similar state. That I could give you this. Am I still sharing the screen? Yes.
Yes.
So I could give you this bit of code and say, well, can you write me something that goes, instead of starting C, D, E, that starts off going A, B, C?
Mm-hmm.
I'm guessing you could give it a go.
Yeah, I think I could manage that.
Yeah, and you could just run the cells again, and your music would appear in the output. So it's this way as well of using code and writing just 1 or 2 lines of code at a time in the cell, and then previewing the output immediately. I think it provides us with a way of sharing, source code for how to do things, and encouraging people to feel that, okay, well, I can spot enough obviousness in that to make a few changes myself and try it. And it's providing us a way of giving people the confidence to start editing things and rerunning things. Another thing about the notebooks is that there's some in here. Maybe there's a notion of something called I haven't got any in this one of magics, IPython magics, and that essentially is me, rather than writing, if I created some magic for this, rather than writing this line of code that imports a package and then something that says converter parse this string, that would just let me do something. It won't work in this, but it's indicative of the sort of thing we could do. I could start to hide the bits of code to write something that says something like tiny notation this, and then if I ran that, it would render the music. So again, I could actually start to hide the code by writing another layer of abstraction, which just says, okay, % tiny notation, and then get the user to write this, and it would display the musical fragment. So we can start to, make higher levels of abstraction that are easier for people to use, that allow them to do codey things without having to actually write code.
Yeah, it just depends on what you want to focus on, whether it's the notes or whether it's the Python or whatever.
Absolutely. And the thing about it again is that you can keep rolling back to viewing the source essentially. So we can provide high levels of abstraction for people to start working with, and then if they want to start tinkering with the code a bit more, they can dip down into lower levels. And again, providing them the environment where this stuff, the packages are all pre-installed.
So that's a pretty good overview of server virtualization and Docker and VirtualBox and cloud. How long before this becomes mainstream for us?
Who's us?
Good question.
I use this stuff every day.
Yeah,
times a day.
I don't, but that's because I have other things I need to do too. But say a college or university teacher. Let's take it there to begin with.
So I mean, there's the two separate bits, I suppose. There's things like the running the Docker applications, and then there's the things like running the notebooks. The notebooks, there are online hosts already. So if you go to notebooks.azure.com, and if you've got Microsoft credentials, or if your institution is signed up to like Microsoft Office 365, you can run notebooks there, logging in with institutional credentials. There's also a service, try.jupyter.org, where you can try out notebooks. But the Jupyter project includes something, there's an application called Jupyter Hub, which is a multi-user service. And the documentation on that is increasingly well developed to allow institutional developers or service operators, or even academics increasingly. There's a service being worked on called the Littlest Jupyter Hub, which tries to make it easier for academics to install services if they've got access to a service and it's connected to the network.
Right.
This Jupyter is a multi-user service, so you can log in, create dummy accounts on it, and have your own working area within the Jupyter Hub.
What was the one I could access with the Microsoft credentials?
No, so authentication. You could the notebooks.azure one. The other one's Jupyter Hub. There are some authenticators being built to plug into Jupyter Hub, right. But they're still being developed. I mean, there are quite a few credential authentication tools available. But that, again, if you're an academic trying to integrate with your institutional credentials, might be a step further than you care to go. I certainly wouldn't count on doing it here. But you know, being able to run these services, the documentations are pretty good to enable someone in an IT department to get it running at scale in an organisation, or an individual academic who has got access to a network server that people can log into could launch one of these things. There are as well, though, there will start to be commercial providers of notebooks. So Adena, which is a UK service, has developed one for University of Edinburgh, which allows the University of Edinburgh students to log in, and they may well start offering that commercially. And if you work in machine learning, or lots of that sort of area, using workbenches provided by commercial data analysis platforms, people like Databricks or IBM's Data Studio or Oracle Data Studio, they all use notebooks as one of their first-class environments. These things are becoming an everyday interface, and it is getting easier to install them. For things like running your own Docker containers, you have to be able to install the Docker application, which if you're working on an institutional machine, you may not be able to do. I know in the AU that people running managed computers can't run these virtual applications on their systems. But I showed how it was possible to launch a server on Digitalocean for not many pennies. So I could deploy things and run things there myself. I think what I'd like to see more of is more institutions offering like Docker machines that you can log into from your desktop. So a server, server acts in the institution where I can log in and run Docker containers on the institutional servers, and then view the interfaces through my browser. That for me would be the thing we should be aspiring to.
An institutional cloud, in other words, basically.
Yes. Yeah. And again, you could start to move into having graphical things. So rather than having to type Docker run and things on my desktop, just giving me a palette of applications, of pre-built containers for different courses or different research groups or different subject areas, where I could essentially just click and launch a container that's mounted. Ideally, it would be mounted against my own online file store, so I could save files to and from that's in my own personal account area. That's something that I think we should be working towards. I think many of the pieces are there. It's just a case of, I think, groundswell of people. I think there's possibly not so much awareness about how you can use these Docker applications as personal productivity, like as containers for personal productivity tools. The Docker containers they're widely used for running services at scale. and the people developing things for those services aren't necessarily thinking that they're thinking about developing services that can be deployed at scale to tens or hundreds of thousands of, or even millions of users. Whereas I'm me on my own wanting to run a personal productivity application. And for me, you know, the Docker environment allows me to do that. It's just the command line tool is not built for people who don't live on the command line necessarily, which is where the Pragmatic application was useful, because that did provide a graphical desktop. So I think there's just a few more pieces. Most of the pieces are there, but the jigsaw needs assembling by someone sympathetic to personal productivity, single user use cases.
Yeah, the single user has been kind of ignored in this.
Yeah. So once more people start realizing the sorts of things that can be packaged and how it can be useful for them as an individual, I think we might start seeing more requests being made to. The thing is, you wouldn't know where to make the request to. One of the things I think is that libraries have got a big role to play in this. That if libraries start championing the availability or making awareness that you can get these prepackaged environments and run them off the shelf, it's where the digital application shelf idea comes in. You know, that might be the way they can start arguing with IT about, well, we need this server provision on the one hand to get the institutional infrastructure support, and on the other hand, they can be helping educate the users to say, well, you've got these complicated requirements or environments you want to run stuff. There is actually a solution to that in these pre-built packaged things. We can help you build them, maybe. And so developing the individual user side. You know, so I see the library as you know, being the place. I'd like that to be the place. I'd like that to be the place where I go to ask for help, not IT.
It'd be better, nicer than going to IT. Yeah. What we haven't really touched on, but it's something I've been thinking about with Grasshopper. Because of course I want to containerize Grasshopper. I did it last year, but it wasn't very good. I'm going to try it again. But using a container application and then storing my data itself in the cloud, say on Google Drive or on Dropbox or something like that, so that I can launch my application wherever and my data persists out there in the cloud. I don't have to just store it on my hard drive.
Yeah, that's the thing. I think I'm not using any bits that do that for me at the moment. I generally store stuff locally to me, or I'm running things in containers where I can mount storage on something like DigitalOcean, where the state persists there. I haven't yet got any things that integrate with Google Drive or with Dropbox. That said, there is Google have got a notebook environment called Collab, and that is tightly integrated into Google Drive. So if you go to, I think it's Collab is the thing to search on. There you can run notebooks, and it will save those to your Google Drive. Yeah, so that's a tight integration there.
It's collab.research.google.com.
Right.
And then you can go from there. External data, drive sheets, cloud storage, etc. Yeah. That's pretty nice.
So again, you know, and people, if you run the IBM service, it will save it to, you know, a personal or a personal account there. The notebooks.azure saves it into a notebooks account that's not integrated, as far as I know, with OneDrive yet, but I could imagine that happening at some point. There are plugins, I think, that you can get for Jupyter that will support integration with Drive, but I haven't. That's not something I've included yet.
One thing at a time.
Yes, I mean, one of the things that we're working to in the OU is looking at finding ways of just hosting this service institutionally and persisting storage for students. We run servers at the moment that they run temporary notebooks, disposable ones. So you log in, it launches the notebook, you can do your activity, then it all gets destroyed. If you want to keep a copy, you have to download it, because that, you know, baby steps. That one doesn't require any authentication. It doesn't require any query. You can essentially do it without permission, largely.
Yeah.
It's as you start to integrate with institutional services, you need a bit more help. And of course, there's more duty of care. If you're saving files, then you've got to, you know, you do want to save them. You don't want to share them to the wrong people. So there's, you know, once you start allowing people to save files on your system, you become responsible for maintaining the integrity of that.
Yeah.
And that's not something I want to worry about.
No, me neither.
I don't want any of the responsibility.
Well, I think this is a good note to leave it on. We've gone
irresponsibility.
Yeah. So yeah, we'll just drop it there and not worry about any of that. You know, there's all kinds of security stuff, and we kind of like skipped over the credentials on signing in back when we were doing Docker. But for those of you who are in the course, so we'll be covering a lot of that stuff later on in more or less detail. Of course, we're not going to cover it in depth, but we're going to cover it enough so that hopefully people will be able to use this without, you know, in my case, my eyes glazing over. Anytime I start doing credentials and like I've stored keys on my hard drive, seriously, my eyes glaze over because it just feels like overhead to me. But it's the way of the future, I think. I just want my little you know, I want my little thing, right? Just plug it in and never worry about credentials ever again. That's what I want.
That would be so nice.
It would be nice. So
I mean, there is that thing that once you've set them up, it is painful setting them up, and it's also a thing you don't do it often. It's hard to remember what you're supposed to do. But the thing is, when credentials are set up, it does make life a lot easier. But it is still it does seem like a painful step.
Yeah. Okay then. So thank you very much, Tony. Really appreciate that. We've had good loyal viewers throughout, 7 throughout, which is very nice. And of course, I'm sure we'll get many more views because this was really good and fascinating introduction to the topic. So thank you very much for joining us.
Thanks for the invitation.
And I hope to see you in person sooner again.
Indeed, yeah.
All right, so from eLearning 3.0, I'm going to close with a flurry of, here we go. Whoops, forgot to share. All right, so here we go. A flurry of screens to close us off. And that was eLearning 3.0. And I don't see anybody in the chat. I wonder if it broke again or, oh well. I'll find out later. Thanks, everyone, and we'll see you again. Bye.
Bye.